This is lesson 3.1, fractions and decimals. In this lesson, we are going to be talking about how to convert between fractions and decimals, as well as how to compare and order fractions and decimals from least to greatest. In your review yesterday, you worked with doing these with all positive fractions and decimals, and in this lesson, we will be including negative fractions and negative decimals to make it just a little bit more difficult. Let's do a quick review first of ordering some decimals from least to greatest, or comparing decimals. So the first two decimals, we have 4 hundredths and 4 tenths. If you recall from your review yesterday, you want to first compare the first place value for each decimal. So they both start with 0 in the whole number space, and then for this first decimal we have in the tenths place a 0, and then for this second decimal we have a 4. Since 4 is greater than 0, then that means that 4 tenths is greater than 4 hundredths. For the second example, again, they both have a 0 in the ones place. In this example, they both have 3's also in the tenths place. So that means I need to go to the hundredths place to compare. And since 5 is greater than 0, then that means that 35 hundredths is greater than 305 thousandths. A common misconception is that this number on the right, 0.305, is bigger because there are more numbers. That is not true. You need to compare decimal place for decimal place until you find one that is bigger or smaller. And then for our third example, we have 0.6 or 6 tenths. That starts with a 6. And then we have 0.6 repeating. So this also starts with a 6. However, this is a repeating decimal, so it's going to continue with 6's forever. On the left, we don't see a 0 here, but I can add 1 as a place value holder. So 0 and 6 is what we need to compare, and 6 is greater than 0. So we put that 0.6 or 6 tenths is less than 0.6 repeating. So be very, very, very careful. Take your time when comparing decimals, one place value for one, to make sure that you are comparing the correct numbers. Another thing we need to know is how to simplify fractions. So again, you did this in your video recording, in your Nearpod review yesterday. 28/42 is the fraction, and to simplify it we need to find common factors that can be divided from 28 and 42. There are 3 factors. They are 2, 7, and 14. Oftentimes we recognize the smaller common factors as they are a little bit easier to recognize. So let's say you recognize that they're both even, so they can both be divided by 2. So if you divide them both by 2 first, you get 14/21, and then you know that those are both multiples of 7, so if I divide by 7, I get 2/3. If you recognize 7 as a common common factor first, you could divide by 7 first and get 4/6, and then divide by 2 and get 2/3. That gives you the same answer. Or finally, if you are lucky enough to recognize that 14 can be divided evenly by both of these, you can simplify in one step and still get 2/3. So any of these methods would work for simplifying fractions. Okay, so we're going to start with fraction to decimal. So if you follow this flowchart, you see that it says to divide the numerator by the denominator. That's the top divided by the bottom. Oftentimes we get confused by this. We want to type the bottom number in first because it's often bigger, but that is not the case. A lot of fractions are less than 1, which means that the top number is smaller than the bottom number, and when you divide them, you'll get a decimal less than 1, and that's okay. So let's try a few examples. To write 4/25 as a decimal, the quickest way is to use a calculator and divide 4 divided by 25. And if you do that, you get 0.16 or 1600ths. Another option is to try to write your fraction with a denominator of 100. So 25 times 4 is 100. And if I multiply the numerator by the same, I get 1600ths, which is the same as 0.16. And lastly, you can always use good old long division by dividing 4 by 25. So that would be set up like this. 25 does not go into 4, so that means I can put a 0 here. I'm going to put a decimal and add a 0. And then how many times does 25 go into 40 without going over? That's 1. 1 times 25 is 25. The difference there is 15 still left over, so I am going to add another 0 and bring that down. And in this case, 25 goes into 150 6 times evenly, so I have 0 left over, and again I have the same decimal, 0.16. This decimal is what we call a terminating decimal, since it stops or ends and does not continue. Let's take a look at another example. To write 3/11 as a decimal, again, you can divide on your calculator 3 divided by 11, and that gives you 0.27272727. Your calculator, depending on what calculator you have, might end in a 7, it might end in a 3. And the reason that it might end in a 3 is because what happens is your calculator will run out of space eventually. So if it's supposed to be a 2 followed by a 7, what it does is it rounds the 7 rounds the 2 up to a 3. When you write your answer, however, you are still just going to write it as 0.27 repeating. You do not need to write all of these out with a 3 at the end. I just wanted to make sure you understand why some of you may be seeing a 3 at the end. And then again, you can also do long division here. 3 divided by 11. 11 does not go into 3, goes in 0 times. So we put a 0, add a decimal, and then add a 0. It goes into 30 twice without going over. 11 times 2 is 22, with 8 left over. Add a 0, bring it down. 11 goes into 80 7 times without going over. 80 minus 77 is 3. Again, we're working until we don't have any left over. 11 goes into 30 twice. That's 22. Once you recognize, wait a second, didn't I already do this? I'm not getting anywhere. I just keep getting the same thing over and over again. That means that that's going to be a repeating decimal. So once you recognize that you are going to just be repeating the same over and over again, that is a repeating decimal, which is a decimal that never ends and has a repeating pattern. So in this case, 0.272727 forever and ever. Here are some common fraction and decimal pairs that I'd like for you to be familiar with, and most of you probably are familiar with most of these already. These are very commonly used fractions and decimals, and it just saves you some time. It makes things a little bit easier if you know them off the top of your head. So 1/10, that's 0.1. 1/4 or a quarter is 0.25. You can think of 25 cents, a quarter of a dollar. 1/3 is 0.3 repeating. 1/2 is 0.5. 2/3 is 0.6 repeating, and 3/4 or 3/4 is 0.75. So try to familiarize yourself with these common fraction and decimal pairs. As I said, that will make things a little bit easier if you have those in your head as you're working through this chapter and in the future. Okay, take a few minutes to convert these fractions to decimals. Three eighths is 0.375 or 375 thousandths. And 5/9 is another one that is a repeating decimal. It's 0.5 repeating. And again, just a reminder, some of you might be seeing this on your calculator ending in a 6. Again, that's just because the calculator cuts it off or stops at a certain point, but it doesn't just cut the decimal off. So it's supposed to be a 5 followed by another 5, but when it stops it, it actually rounds, the 5 rounds this 5 up to a 6. You do not need to write that. You can just write your answer as a repeating 0.5. Here are a few examples of some other decimals that will round up at the end, and you want to be very careful. So 2/3 is 0.6 repeating. You might see 0.6666666666667. Again, do not write it like that. There's 0.6 repeating. 7/11 is another one, is 0.63 repeating. You might see 0.63636363634. Do not write all that out. That just rounds up at the end. And then one more. 1/9, this is 0.1 repeating. You'll notice that one like this does not round up at the end, and that's because a 1 would not round a 1 up to a 2, it just would keep it the same. So some of them you'll see the rounded up at the end if the number is bigger than 5 or bigger. If it's less than 4 or less, you will not see it round up at the end. So just be careful and be on the lookout for those repeating decimals on your calculators. Okay, now we're going to go the other way, turning a decimal into a fraction. And this says write the decimal as you would read it, and then simplify. So for this, you have to really be able to read the decimal properly. So for this first example, that I mean not 0.48, you are going to read this as 48 hundredths. That's how this is read. If you can read that, then that's exactly how you write it as a fraction, 48 over 100. And then you are going to simplify this. Again, you can look for any common factors that you can find. You might find the biggest factor first, and that's great. But maybe you also only recognize 2, and then you have to divide it by 2 twice. Well, that's fine. And this second example is read as 1 and 325 thousandths. So again, if you can read it correctly, then you can write it 1 over 325 1,000ths. And just for the sake of not making this video run into too long, the greatest common factor here is 25. And again, if you don't recognize 25 first, that's okay. Maybe you recognize 5 and you divide by 5, and then you divide by 5 again. That's also fine, but just for the sake of time, I'm going to do it in one step by dividing by the greatest common factor, which is 25. So that gives us 1 and 13/40 as our fraction in simplest form. Okay, so now we're going to use all of that to help us compare and order fractions and decimals. My favorite suggestion for how to do this is to convert all fractions to decimals, which is a little bit easier than the opposite, converting decimals to fractions. I think it takes less time. If you have a calculator, all you need to do is divide the numerator by the denominator. So step 1, convert all fractions to decimals. Step 2, compare each place value starting at the 10th place until you find one that is different. And then if you are rewriting them, write them in their original form. So if you changed a fraction to a decimal, write it back in its fraction form in your final answer. So we're going to be, as I said, we're going to be working with negatives in here, and this is where things can get a little bit trickier. So I'll make sure to take a little bit more time with those. This first example, however, is all positive, so 3/4, again, if you already know, is 3/4, which is 0.75. If you didn't know that, divide 3 divided by 4, and that'll give you your decimal. Since they both have a 7 in the tenths place, we have to look to the hundredths place to compare. 5 is greater than a 0, so that means 3/4 is greater than 7/10. For this second example, we have -5/10 and -0.54 repeating. So we need to be very, very, very careful when we're thinking of these, because negatives are backwards in terms of greater and less than positive. So let me just use some whole numbers here to remind you of what I'm talking about. Okay, so let's say we have a whole number, +3 and -3. The farther it is from 0 to the left, the smaller it is. The farther it is on the right on a number line, the bigger it is. So +3 is obviously greater than -3. +3 is also greater than +2. However, if we're talking about -3 and -2, -2 is actually bigger than -3 because, like I said, the farther we go left on the number line, the smaller we get. So you have to be very careful with the negatives. So -0.5, again, same thing, start by comparing the tenths place. They're both 5s, so we're going to move on to a 0 here in the hundredths place and a 4 over here in the hundredths place. Typically, we say 4 is greater than 0. However, these are negatives, so it's the reverse. -4 is actually less than this -0 here. So this -0.5 is actually greater than -0.54 because this one would be farther from 0, okay, on the number line. Let's try some more with negatives. Here we have a mixture of fractions and decimals, and we're going to put them in order from least to greatest. So the first thing I'd like for you to do is change the two fractions to decimals. So -1/4, if you divide 1 by 4, that's 0.25. And since it's negative, we can just put the negative back on the front there. So that's -0.25. And then 3/5, 3 divided by 5 is 0.6. So we have -0.25, 0.6, -3, and 0.8. Okay, the positives, 0.6 and 0.8, those ones are going to be in order just as they normally would be. But with the negatives, you have to be very careful. So we have to decide which comes first, which is smaller, -0.25 or -0.3. So let's take a look here. There's a 2 in the tenths place here and a 3 in the tenths place here. Again, typically 2 is less than 3, but since these are negatives, it's the opposite. So -0.25 is actually bigger than -0.3, which means -0.3 is our smallest. So this is going to go first. Our -0.25 is going to go second. And then 0.6 is less than 0.8, so that comes third. And then lastly, 0.8 comes last. So when I rewrite all of these, we're going to write them again in their original form. Let me get rid of all this so you can see the final answer. We're going to write them back in their original form. So the fractions are written as fractions again in our final answer. Okay, here's a couple of just extra practice for you to try since these are a little bit trickier. This is similar to the first one we did, but with negatives. So -0.75 compared to -0.7. Again, typically we would say that 5 is greater than 0, but since it's negative, it's the opposite. So that's a less than. For our second example, 5/7, negative 5/7 is negative 0.7142857, and it keeps going on and on and on. I don't need to write down every single decimal place. I just need enough so that I can compare with the second decimal. So here they both have a 7 in the 10th place, and then this one has a 1 in the 100th place, while this one has a 7. So really that's all I need are the 2 place values. Since 1 is typically less than 7, since they're both negatives, it's the reverse. 1 in this case would be greater than 7 since they're negative, and 7 would be farther from 0 to the left on the number line. Okay, so as you're working on these examples on your homework, please be very, very careful. Take extra time when working with the negatives. Make sure you're really thinking of the number line, and if you have any questions, let me know.